Hello everyone, my name is Ahmad Nanda Yuma Rafi. I'm from Mercubuana University, Jakarta. Here I want to try to present what is basic concepts and computer evolution, especially in computer architecture materials. So let's check it out. And then in this presentation, I will also describe about the organization and architecture of the computers, a brief history of the computers, the evolution of the Intel x89 architecture, embedded systems and IoT, ARM architecture, and the last is cloud computing. And the fourth is organization and architecture. Based on the definition of the computer architecture, which refers to those attributes of a system visible to a programmer that have a direct impact on the logical execution of a program. A term that is often used interchangeably with computer architecture is instruction set architecture, or ISA. The ISA defines instruction formats, instruction opcodes, registers, instruction, and data memory, and the effect of executed instructions on the registers and memory, an algorithm for controlling instruction execution. But for the computer organization, it refers to the operational units and their interconnections that realize the architectural specifications. And then the history of the computers. In the first generation, the computer is built using the vacuum tubes. The first generation of computers used vacuum tubes for digital logic elements and a memory. A number of research and then commercial computers were built using vacuum tubes. And a fundamental design approach first implemented in the IAS computer is known as the stored program concept. The idea is usually attributed to the mathematician John von Neumann Alan Turing. And the second generation using transistors. The transistor, which is smaller, cheaper, and generates less heat than a vacuum tube, can be used in the same way as a vacuum tube to construct computers. Unlike the vacuum tube, which require wires, metal plates, a glass capsule, and a vacuum, the transistors is a solid-state device made from silicon. We know in the second generation of the computer, the usage of the silicon is began. For the third generation is using the integrated circuits. A single self-contained transistor is called a discrete component, and discrete components were manufactured separately, packaged in their own containers, and soldered or wired together into machined-like circuit boards, which were then installed in computers, oscilloscopes, and other electronic equipment. In the later generation, in the 1950s and 1960s, most computer memory was constructed from tiny rings of ferromagnetic materials, each about a sixteenth of an inch in a diameter. These rings were strung up on grids of fine wire suspended on small screens inside the computer. In the later generation, in the later generation, the memory of the computer is involved. And this is the architecture's example. There are two architecture over here. The first is from the first generation, which used the vacuum tubes, and in the right is IBM 1794 computer. And then I will explain about the evolution of the Intel x89 architecture. As we know, the Intel had launched their first architecture, which called x89 architecture, because of every product that they launched at that time, the last number is always used 86. So their product or their architecture at that time is called x89 architecture computer. But they changed their product name to Pentium because of number can't be registered as a trademark. As you can see in the table here, it consists the evolution of the first generation of the Intel product and the latest generation of the Intel product. And then I will explain about the embedded systems and IoT. Embedded system refers to the use of electronics and softwares and microprocessors based on computer hardware system with software that is designed to perform a dedicated function. either as an independent system or as a part of a large system. At the core is an integrated circuit designed to carry out computation for real-time operations. So the basic example of the embedded system, electronic which use embedded system is a calculator. Because of calculator has a specific purpose, to do to do a calculation. And the next is the Internet of Things, or IoT. It's a term that refers to the expanding interconnection of smart devices ranging from appliances to tiny sensors. A dominant theme is the embedding of short-range mobile transceivers into a wide array of gadgets and everyday items, enabling new forms of communication between people and between things to themselves. We know that the internet can connect people by using a device like or handphone or smartphone. But internet also can connect the thing. So the example of the Internet of Things is the smart home. So here I will explain about ARM architecture. The ARM, or Advanced Reach Machines, is a family of reduced instruction set computing, or known as RISC architectures, for computer processors configured for various environments. ARM Ltd develops the architecture and licenses it to other companies. So basically, the ARM Ltd is not selling like a processor or chip, but they sell the license of their product or their architecture, including system on chip and also system on modules. And ARM performs single operation at a time. This makes it work faster. It has lower latency, that is quicker response time. ARM processors are designed so that they can be used in case of multiprocessing systems where more than one processors are used to process information. So the last is cloud computing. The concept of cloud computing is defined as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources like network, servers, storage, application, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. So the basic example of the cloud computing is like Google Drive if you use cloud computing as a storage, and then cloud networking refers to the networks and network management functionality that must be in place to enable cloud computing. Most cloud computing solutions rely on the internet, but that is only a piece of the networking infrastructure. One example of cloud networking is the provisioning of high performance and or high reliability networking between the provider and subscriber. Cloud storage consists of database storage and database applications hosted remotely on cloud servers. Cloud storage enables small business and individual users to take the advantage of data storage that scales with their needs and to take advantage of a variety of database applications without having to buy, maintain, and manage the storage assets. So using cloud computing, especially for cloud storage, you don't have to buy a server. So you can save your data or your files over there. So you can reduce your cost for only using this cloud storage. I think that's all from me. Thank you for watching my presentation. I hope you can get new knowledge, especially about computer architecture, and see you later.